Area between curves. Suppose we are given two functions y equals f of x and y equals g of x, and they are continuous on the interval a to b. The graph of f of x is above the graph of g of x. Now the area between these two curves and the interval ab will be defined by the definite integral a to b. First we write f of x minus g of x. In this case, clearly notice that f of x minus gx is positive. So we see that my interval a left point is here and the right point b is on this side, and this is my graph of the function gx, and this one is the graph of function f of x. That's why we said f of x is bigger than g of x. That means y values are greater on f of x compared to g of x. Now what happens if we take this line here above? So we get some region bounded by this, and we are interested to find the area of this one. So this one exactly will be this definite integral. So we just need to check where we have our f of x and where is g of x. If g of x is above f of x, then we switch it to gx minus f of x. On the other hand, suppose x equals fy and x equals gy are two continuous functions on an interval ab on which fy is greater or equal gy. In this case, the graph of fy is on the right of the graph of gy. Then the area between the curves is the definite integral, goes from a to b. Now we write fy minus gy, and our integration will be with respect to y. And let me show you graphically how does it look like. Suppose this is my graph fy and this is my graph gy, and now we have interval from a to b on y. So then you can see the region bounded by these two curves, and between ab is this one. Now we are taking integration over y-axis, so that's why we have a to b, and then our integral goes with respect to y. Now, so the right side function is fy and the left side function is gy. That's why we write like this. So this way you will decide how you need to take, or how you need to form your integral. Is it on x-axis or y-axis? There are many situations both can be applied.
So in this problem, we want to find the area of the region enclosed by x equals 7y squared and x plus y equals 6. And to do that, we need to decide whether we're going to be integrating with respect to x or y. So the first thing we want to do here is to graph the region. And in order to do that on a graphing calculator, we need to have both functions expressed in terms of x. So let's look at the first one where we have x equals 7y squared. So right now we would like to solve for y. So we'll divide both sides by 7 and we'll have y squared equals x over 7. And now, taking the square root of both sides, we would have that y equals plus or minus the square root of x over 7. So we would be graphing y equals the square root of x over 7 and y equals minus the square root of x over 7 to get the complete picture of this function. For the second one, it's a little bit more straightforward. We have x plus y equals 6, and solving here for y, we have that y equals 6 minus x. So these right here are the things that we're going to graph on the graphing calculator so that we can see the region. So now we have our calculator here, and you can see that for y1, we've graphed the square root of x over 7. For y2, we've set it at negative the square root of x over 7. And y3, we've set to be 6 minus x. The next thing you do is to check and make sure that next we want to see that we have a window that's going to allow us to see the graphs of both of these. So here you can see I've set my window for x to run between -2 and 10 and y to run between -2 and 2. But for different examples, you may need to play around a little bit with those values in order to get the graph. Next, we hit graph and we see the graphs of these two functions. So what we see here is that the x equals 7y squared is a sideways parabola, and the x plus y equals 6 is a line. So now we need to decide whether we're going to be integrating with respect to x or y. So let's look at this. If we were integrating with respect to x, what would that be? So here I've just sketched the graph, and what we notice here is that if we're integrating with respect to x, which would be the top minus the bottom, once we get to this region here, or this line here, we're going to have two separate integrals that we'll need to solve. However, if we looked at this in terms of y, so that would be the right minus the left, we'll see that the entire region is bounded by the same functions. So now that we've decided to do this in terms of y, we're going to need to find the y coordinates for the edges of the region. So in this case, what we will need to do is to set x equals 6 minus y equal to 7y squared and solve. So we have 7y squared equals 6 minus y. Putting all of this on one side, we have 7y squared plus y minus 6 equals 0. And now this is a quadratic equation, which we can solve using the quadratic formula, and the result will be y equals -1 and y equals 6/7. So these are now the integral bounds. So here we have -1, and here we have 6/7. So now let's set up the integral. So now we will be integrating between -1, the lower bound, and 6/7, the upper y bound. And we want the function that's on the right, which in this case is 6 minus y, minus the function that's on the left, which in this case is 7y squared, and we're integrating with respect to y. And now this is simply using the power rule backwards, and if we solve this completely, we will get 2,197 over 294. And this here represents the exact area between the two graphs.